All right, have your homework handouts out, and just 8 problems for you, 4 equations for you to solve, and then 4 inequalities involving absolute value. Key step to absolute value, whether it's inequality, whether it's equation class, is to first isolate the absolute value. And then you're either going to set it equal to positive, negative, if it's an equation, or if it's an inequality, it'll either go class, well, yeah, it'll become compound because you'll put it the thing not equal to, but in between the positive, negative, or outside the positive, negative. So equation equals positive, negative, less than in between the positive, negative, greater than outside the positive, negative. Yes?
My thumb is kind of bleeding.
Only kind of bleeding?
It's kind of getting all over my hand.
All over your hand. Do you need a tissue? Do you need duct tape?
That'll work.
That's usually what I use, duct tape. Just duct tape the wound.
Super glue.
Stop it from spurting all over the place. We don't want to get all over Brandon. All right, so as we look at number 1, we have the absolute value of 2x minus 4, minus 3 is equal to 11. The first thing that we had to do here, Audrey, was to... By doing what? There we go, add the 3. And when you do, you get it isolated. Absolute value 2x minus 4 is equal to...
14.
There we go. And then we'll set it equal to both positive and negative. 14. Again, not in between nor outside, just equal to both of them because it's an equation. And in both cases, class will need to add the 4 to both sides and end up getting 2x equals, well, 18, so that x is equal to 9. And 2x is equal to negative 10, so that x is equal to negative 5. How many had 9 and negative 5 for number 1 on the handout? Questions on that first one?
I added 3, but then I got 13. Except 14.
Yeah, so you got weird fractions then. That's a bummer. All right, looking at the next one. First thing we should have done here, Brandon.
Isolated.
By doing what?
Subtract 4.
To get the absolute value of x, negative 7 is equal to?
Negative 3.
And then what do we need to do once we've isolated the absolute value, Brandon?
Right, no solution.
Yeah, because it's equal to a negative. We don't set equal to both positive and negative. It can't equal a negative, so just no solution. How many had no solution for number 2? Excellent. Number 3. What do we need to do here, Abby? 2 steps, actually.
Add 5.
To get
20.
And then
divide by 4.
to get the absolute value of negative 2x, negative 3 is equal to 5. Now that it's isolated, now we do what?
Make 2 equations.
Equal to?
5 and negative 5.
Positive, negative. So it's always about the positive, negative, just whether it's equal to inside or outside. In this case, equal to. In both equations, we're going to have to
add 3.
Here to get
8.
And here when we add 3, we get
negative 2.
And so we divide it by negative 2 to get x equals
negative 4.
Or
1.
Positive 1. How many got those 2 answers on number 3? Excellent. Number 4. What do we need to do first here, Michael?
You need to get the 1 away.
Yeah, get rid of the 1, and when we get rid of it by moving it to the other side, we already had a 9x plus 5. That negative 1 comes over as a positive 1. It joins up with the 5 to get us a 6. Then the next thing we'll have to do, once we've added the 1 to get 9x plus 6, is to
divide by 3.
Divide both sides by 3. Now, of course, on this side, you divide away the 3. You've isolated the 2x minus 1. But what do you get when you divide 9x plus 6 by 3?
3x plus 2.
Good. Remember, division of a polynomial by a monomial. We just divide this by the 3, then divide that by the 3. And now we're ready to do our positive, negative. What are my 2 equations going to look like?
2x minus 1 equals 3x plus 2. 2x minus 1 equals negative 3x minus 2.
Excellent. Change both signs here. How many got to this point? Excellent. All right, take it from here, Michael.
You are going to move the 2x over to the 3x side, which will give you 1x, or essentially just x. Then you're going to move the 2 over to get negative 3, and next x equals negative 3. Then you're going to move the negative 3x over and get a 5x. And then you're going to move the negative 1 over to get a negative 1. And then you get x equals negative 1/5.
All right. But before I circle these answers and say that I'm done, thoughts?
You got to check.
Because
1 can be extraneous.
Right, because there's an x that wasn't in the absolute value. How many noticed as you were solving, wait, there's an x outside the absolute value. I'm going to have to check these solutions. How many forgot to check the solutions? Gavin. All right, so just kidding. All right, so everybody here checked. That's good. All right, so we're going to plug it back into the original problem, which is annoying. And which value do you want to test first, Michael?
I'm going to go with -3.
All right, so let's go with the -3 here and the -3 here. Of course, 2 times -3 class.
-6.
Minus 1.
-7.
Absolute value -7.
7.
Times 3.
21.
Minus 1.
20.
All right, and then 9 times -3
-27.
plus 5. Oh, did that work out, class? No. Well, that means probably the answer is -1/5, because usually you don't get both extraneous, but let's check anyway. Calculators at the ready if necessary. 2 times -1/5, don't make this too hard. -2/5 minus 1.
-1 and 2/5.
-1 and 2/5, or -7/5 times 3.
21/5.
-21/5, good. That's why I like the improper fraction. Minus 1 or 5. Oops,
Don't we do absolute value?
sorry.
Yeah.
7/5, absolute value is 7/5 times 3 is 21/5, minus 1, which becomes a 5/5.
No, 16.
16/5. All right, so we end up with a 16/5 or 5 and 3 and 1/5, I guess. All right, and then over here, 9 times -1/5.
-9/5.
-9/5 plus 25/5, which would be 5. 16/5. And sure enough, my gut was that it should check since the first one didn't, and it does. How many found the -3 to be extraneous and the -1/5 to work? How many just guessed the nice, easy one would work and the other one wouldn't, and you just moved on with life? Not careful there. Questions? Questions on the checking? Any questions on calculator usage? Any questions there? All right. Let's move on then to the inequalities, which is all of this we had done before the exam. Of course, it was not on the exam, but it was all done before the exam. Let's go on to the stuff that we talked about in our last lesson since the exam. Those were the inequalities. And again, if absolute value is greater than something, class, then I'm going to put the absolute value outside the positive negative. If it's a less, then I'm going to put it in between the positive negative, unless it's less than a negative. No solution, or greater than a negative, all real numbers. So as we look at number 5, I have the isolated absolute value of r plus 4 greater than 6. Again, I've isolated the absolute value, but I'm not going to set it equal to positive -6, class. I'm going to set it, it's greater than outside the positive -6. Okay? Now, if you want to, you could drive a little number line right with the -6 and the 6 and put the r plus 4 here and the r plus 4 there. Or you say, wait, it's going to be outside the positive -6. So the -6 is going to be small. You can kind of picture the number line as opposed to drawing if you're really lazy and say, well, I know the r plus 4 is going to be less than the -6. It's going to fall outside the positive 6, meaning the r plus 4 is going to be greater than the 6. You could go straight to this without the number line, frankly. Okay? And then from here, in both cases, to solve, it's one step. Subtract the 4 from both sides to get r is less than -10, but r is also greater than 2. How would I express those, though, in the interval notation? Kendall?
You have parentheses, -infinity, -10, parentheses, and then you have 2, and then infinity, and parentheses.
And there we go. How many have that answer for number 5? All right, questions on 5? Questions on 5? Is that a question? You got it, or a handed question? Okay, late hand, we got it. All right. Looking at the next one, we again have an isolated absolute value of x -3 less than or equal to 1. Again, the keys are always isolate, positive, negative. It's already isolated. Let's do our positive -1, but it's not going to equal positive -1, class. It's going to go in between the positive -1. So I've got my -1 and my positive 1, and the x -3 is going to fall in between the two of them with our less than or equal to signs. Again, you could draw the number line, or you could just go straight to this. One step solves it, class. Add the 3. What do we get, Maddie? Or in the interval notation, And there we go. How many have an answer for number 6? Questions on number 6? Well, looking at number 7, again, it's already isolated. All right, so I've already got the absolute value of negative m negative 4 less than negative 5, and whenever it's less than, class, I know it's not going to be equal to positive negative, it's going to fall
No solution.
normally inside the positive negative, but it's less than a negative. So class, no solution. How many noticed no solution? How many said it in between the positive and negative and did all that work? All right, enter sad. All right, so we move on to number 8 then. And once again, this is, it gets boring. It's already isolated again. And greater than or equal to negative 37. So what do we do here, Brandon? Yeah, again, normally we do our positive negative, but it's already a negative here. Absolute value is always bigger than negative. Answer here is all real numbers. How many all real numbers for number 8? Question.
If it's or equal to negative 37?
Well, it's that or the other. Well, obviously, it's not going to be equal to. But all real numbers will be greater than, for instance, for how many of you am I greater than or equal to your age? All of you. Now, I'm not equal to any of your age, but it was either greater than or equal to. I didn't meet the one requirement, but I met the other. Does that make sense now? All right, good. Good question. Really good question. Any other questions? Anyone perfect on all 8 of these? All right, how about 7 for 8? 7 for 8? Okay. All right, 6 for 8. You got one right? Just kidding. Questions on any of this? Questions on the ones we missed? Yes, ma'am.
Can you just go to number 1?
Yeah, on number 1, and again, you may be well served to watch the first, 8 minutes of the video, but I'll go ahead and go over it again really quickly. So, we've got to isolate, and again, all of the inequalities were isolated, right? But for this one to isolate, I've got to move the negative 3 over as a positive 3 to get a 14. And then I've got, again, I'm not going to set it between the positive negative 14 or outside the positive negative 14. It's just equal to positive and negative 14. So it's equal to 14. It's equal to negative 14. And then I'll add the 4 in each case to get 2x equals the 18, 2x equals a negative 10, and there I get 9 and negative 5 for the answers. Make sense? All right, and again, if you'll rewatch the first 8 minutes or so, you'll catch the first 8 minutes that you missed while you were taking care of the pizza day stuff. All right, let's set that aside if you would, please. And turn to page 82 in your textbooks. Page 82. I want you to do 4 problems on page 82 in the practice section, numbers 10, 13, 17, and 18. So the practice section of page 82, not the review, the practice at the top section, 10, 13, 17, and 18. We're not going to actually graph the solutions on the number line. Too lazy. Makes sense. You guys better in this problem. All right, pencils down even if you're not finished. And we're going to do these shortcut method. Okay, so we've worked the long cut method. You should know that method pretty well. And if you hate my shortcut, that's fine. But here's how lazy me does this. It's isolated. I know there's really a positive and a negative 9 I'm interested in, right? I'm not even going to worry about inside, outside yet. It's just there's a positive, negative 9. And that knocks off absolute value. I'm then going to add 3. By adding 3 to the positive 9, that's 12. Adding 3 to a negative 9 gives negative 6. Then we're going to divide them both by 4. That gives 3. That gives negative 3 halves. And I know I'm going outside ranges, right? So I'm going to go smaller than the smallest, bigger than the biggest. Negative infinity to negative 3 halves, and then 3 to infinity. I have the or equal to, minimal work shown. Now, you don't get a whole lot of partial credit doing it this way, but that to me is the quick way to do it. How many got these answers? Okay. Questions on that? What? Oh, you were saying bless you. Okay. Looking at the next one, same thing. I know for absolute value's sake, there's really positive negative 31. So I'm going to add 5 to both of them. Positive 31 plus 5.
36.
Negative 31 plus 5.
26.
Negative 26. I'm going to divide both of them by 12. Divide this by 12, I get. Divide this by 12, I'm going to reduce it to get.
Negative 13 over 6.
I'm going to go inside here, right? So it's going to be small to large with brackets. Boom. Done fast. Again, I'm lazy. This is my uber lazy way to do it. But do you see that technically I'm still doing all the same steps? I'm just not writing very much? How many got this answer on the second one? All right, questions on this? All right, let me show the long way on this next one just for reiteration's sake. I've got an inequality. I know I'm going to have a positive 26. I'm going to have a negative 26. Because I see less than class, am I going in between or outside?
In between.
I'm going in between. So I'm going to put the 14n minus 2 in between. I'm going to say that negative 26 is less than, not less than or equal to, 14n minus 2 is less than 26. All 3 spots I need to put a positive 2. And that'll get me negative 24 is less than 14 and is less than 28. And then all 3 places I need to divide away the 14. And of course, we're going to have to reduce this down to get
12/7.
negative 12/7 is less than x is less than 2. And then so to want it in the interval notation, I'll put parentheses around the negative 12/7 to 2. And there's my answer. By the way, it's exactly what I was doing a moment ago. It's just a little bit more writing, but a lot more partial credit in case you somehow botched that answer. How many got that answer on the third one, number 17? All right, questions on this? What on the last one? Obviously, we start by dividing the 3 away. Then what, Genesis?
2 equations.
I will get 2 equations because I got the greater than. So I'm going not between the positive negative 40, but outside the positive negative 40. If we were to start with the number line, okay, here's negative 40, here's positive 40. I know they're really close together, but like, little check marks are really close too. All right, so it's going to fall outside the positive negative 40, this 6x plus 4. What are my 2 inequalities that I'll write?
X plus 4 is greater than -40.
It's going this way,
Oh, less than.
less than or equal to negative 40, and,
6x plus 4 is greater than or equal to 40.
all right,
Subtract 4. Negative 44.
I think I heard a soda can. Is that what that was?
Mhm.
Okay, all right.
Negative 4. Oh,
Oh, I'm sorry, you're coming over to negative 4 on both sides. Get 6x is greater than or equal to
36.
36.
And divide by 6.
By the way, we have a negative, but we're not dividing by a negative, so don't flip the sign around. Let's just reduce it down. Maybe type it in as a fraction on your calculator. 44 fraction 6.
7 1/3.
Negative 7 and 1/3. Of course, we'll put the negative back on ourselves because we're too lazy to type the negative into the calculator, but we know it's still there. And then here, we end up getting x is greater than or equal to 6. So how do I write my answer in the interval notation?
Negative infinity. Negative 7/3.
By the way, negative 22/3 if you didn't have your calculator do it.
And positive 6. Infinity.
And there we go. And how many have this answer on number 18? Ooh, questions?
I just didn't finish it.
All right. Questions on absolute value inequalities. You're going to practice a little bit more with this in your homework this evening, and then tomorrow you've got an opportunity to demonstrate how well you know how to work with these. However, we're going to move on, and next thing in your notes, rational equations. Next section in your notes, rational equations. The root word of rational is the word, class, ratio. And a ratio is generally written as a fraction. So rational equations are equations with fractions. Those who had me in Algebra 1, how do I feel about equations with fractions in them? Well, you say the right words, but the emotion is lacking. Gavin did a great job behind his computer a moment ago. Try to imitate what Gavin just did there, Genesis, because you know exactly what he just did. Yes. Maybe Maddie could help us. Maddie's no actress. Okay. Audrey Kendall, it's been a couple years for you. Do you remember how I feel about fractions and equations? I hate them. So I get rid of them. Like if I hated Brandon, I would get rid of Brandon. Hate Michael? Get rid of Michael. I don't know why I pick on my 2 favorite students from yesterday, right? We get rid of fractions. We don't want to mess with them. They mess with stuff. So we hate them. We get rid of them, right? But there's a right way and a wrong way, right? The wrong way would be to take out a knife and just stab him in the heart, okay? The Bible says you can't do that. But I could use my position here at Grace Christian School and my influence to get him kicked out so I don't have to look at his face anymore, right? And that would be doing it the right way of getting rid of Brandon, right? The wrong way to get rid of fractions is to just slash them out. You don't get to do that, okay? But if we go through channels, we do things the right way, we can get rid of fractions. By the way, for the record, I don't want to get rid of Brandon. We love Brandon. We're happy he's in this class. All right, anyway, there's my disclaimer. You could hear the sincerity dripping from every word, couldn't you? But anyway, we're going to get rid of fractions because we hate them. But the right way to get rid of fractions, this is the most important thing to remember, those who've had me before, is to do what? Oh no.
Multiply by the denominator.
you're really close. Multiply everything by the LCD. Write that in your notes with a big star next to it. Under rational equations, multiply everything, underline that word, maybe write it in all caps, by the LCD. The reason for that, and the reason for the goofy emphasis, because students come through and then they don't multiply everything by the LCD and they get wrong answers. And it's sad. Everything, even if it's not a fraction, everything gets multiplied by the LCD. Try to be fair and equitable here. Because what you do to one thing in an equation, you have to do to everything in an equation. Usually here, what you do to one side, you have to do to the other side, and that's true. But another way to say it is what you do to one thing, you have to do to the everything. So I see equation, I see fractions. I have feelings of hatred. I hate these fractions. So I'm just going to get rid of them. I'm going to multiply everything, class, by what LCD? I got a 3, I got a 15, and a 5. What one number has all of those in it? 15 has all of them in it. So I'm going to multiply everything by 15. Now, technically, that's a 15 over 1, remember. So although I'll write a 15, it is over 1, which means this is a numerator 15. That's a denominator 3. I can cancel to get 1 and 5. However, I'm lazy. I don't write the 1. I already know it's going to be a 1. It better be a 1. If it's not a 1, I didn't multiply by the LCD. But if I multiply by the LCD, it's always going to be a 1 down here. So what I really have is a 5 times 2x. 10x. Here I've got to multiply by 15 as well. Well, that's negative 15 times 1. You're doing this with me, by the way. I should have said that. Did I say to write this down? No, write that down. You're doing this with me. Now we have a nice example right there at the front of your notes. So when you're like, how do I do this again? I can't remember multiply everything by the LCD very well. Even though, I don't know how many times we said that in Algebra 1, so some of you are hurting my feelings here. It's okay. I'll get you kicked out. All right. Okay, Michael, he knew something about multiplying by denominator at least.
I wasn't here.
Okay, Brandon has an excuse and Abby has an excuse. I didn't have that there. Yeah.
She was in the curriculum. No.
Oh. All right. And then here we're going to multiply by 15. And what's going to happen to this 15 and that 15, class? They're both gone. So all I'm left with is a negative and an x. The term does not drop out, just the denominator and the 15 to get negative x. And then here I'm going to multiply by the 15. And the 15 and the 5 are going to cancel, and I'm going to get a 3. By the way, you think I'm joking. You notice Brecken ain't here no more. Yeah. Least common denominator then. I'm just kidding, Brecken. All right, 3 times the 3x. 9x. And then 15 times the negative x.
15.
Negative 15x. How many remember doing this now? Okay, more of you. I'm getting off sort of from Kendall. That still is sort of depressing. All right, and now look, it's like any other equation we've been working this whole time. Get rid of parentheses if there are any. Combine like terms. Okay, that we can do, right? To get, wait a second, 9x minus 15 equals 9x minus 15x. I can cancel the 9x's away, right? And then, by the way, since this is a negative and that's a negative, I could just cancel the negatives. And then when I divide away the 15 from both sides, I get x is equal to 1. That was easy because we got rid of the fractions. You try to work with those fractions, it's a mess. I don't want to mess with those fractions. I like equations, but I hate equations with fractions because I hate the fractions. So get rid of them. Multiply everything by the LCD. How many remember learning this now in years past? Brandon still does not remember. Does it make sense at least? All right. So we're going to give a couple of these a try. They're at your seats. I'm going to pass out a handout to you. You can put your books away. You won't need them for a couple days. I'm just kidding. You'll need them for your homework tonight. All right. And I'm going to pass out a handout. Some of these are slightly used, but it was before Corona, so they're safe. The last time we used these was before coronavirus became a thing. So even though these are slightly used, they're Corona-free. So no. Yeah. All right, I want you to do just numbers 1 and 5 on this page. Number 1 and number 5 on this page. If you're watching on YouTube, pause for a moment and print off the link, the document that's linked there in the description, and then resume the video with us. 1 and 5 on this handout. And you probably want to work on a separate piece of paper because there's not a whole lot of room to do the work directly on the handout. Also, then I can't reuse the handout if you write on it, and I'm lazy, and I don't want to reprint. Right, Michael? And everybody else? Well, you were. Let's see, who didn't write on their handout? Everybody wrote on the handout. You can write on the handout, Brecken. You're already gone. Okay, so I was going to go with you, Gavin, but I got Scott when we taught this in Algebra 1, so I'm like, I can't get both of them. His mom will start wondering if I think I actually hate them and actually try to orchestrate something. So I'm like, I'll pick on Brecken instead. I had nothing to do with the transfer to Japan, all right? It's not me. Even though I said it wasn't Algebra 1, I was lying. Hate empty water bottles. Get rid of empty water bottles. Crush them. Anger management therapy. Some people crush Coke cans on their forehead, but that hurts, so I don't do that. One and five. Audrey's finished. I'm really glad you have a calculator. Yeah. I like you having a calculator too because it means I can give you big numbers. In Algebra 1 I had to be nice with little numbers, but now I don't have to be nice because you have a calculator anyway. I can do whatever I want. It's great. Gavin and Brecken are getting impatient waiting for y'all to finish. So let's go and take a look at these together. Number one, what is the LCD, class? 35. I'm going to multiply everything, even the 24, by 35. Everything gets multiplied by 35. And the whole point of multiplying by the LCD is to get rid of the fractions. And the only way you get rid of a fraction is by knocking out the denominator, right? If there's no denominator, there ain't no fraction no more. So we're going to knock out the 5, class. It's going to leave me with a 7 times z is 7z. We're going to do the same thing here. Bam! Knock out the 7, left with a 5, so positive 5z. And on the calculator, aren't you thankful? 35 times 24. I'm going to take his word for it. Well, actually, that's probably not best. How many also got 840? Okay, now we'll take his word for it. And we'll combine like terms, class, to get 12z equals 840. We divide it with the 12 and we get z equals 70. And that was super easy. And we got 70 on the first one. All right, questions?
I got it now. I wasn't comprehending it at first, but now I
Okay,
got
it makes sense now. Okay, let's go to the next one. Ooh, 7, 6, 3, and 14. That's not quite such an obvious LCD, right? What is the LCD?
42.
It is 42. Now, if you couldn't figure that out, what you can do, and this is the long way, not a wrong way, but the long way, would be to prime factor everything. Of course, this is already prime and this is already prime. and you find all your winners. Well, nothing has more than 1, 2, nothing has more than 1, 3, and nothing has more than 1, 7. So you multiply the 2, the 3, and the 7 together, and that's where you get 42. That means the long way. Here's the easy way. You look at a big number. Can these all go into 14 evenly? Nope. Try doubling a 14. What's that? 28. Can they all go into 28 evenly? Nope. Okay, try tripling it. What's 3 times 14? 42. Can they all go into 42 evenly? Yep, there it is. So there's 2 ways to do it. You start with a big number, and times 2, times 3, times 4, times 5, until you finally find a number that all works, or prime factor and come up with it that way. But 42 is our number. How many found 42 to be the number? How many did not find 42, and that's what was taking so long? All right, so let's multiply everything, even the 2, by 42. And Maddie, here I'm going to cancel to get a 6, which gives us, you have to multiply the 6 by the 15 to get 90 and then here the 42 and the 6 will cancel to give me a, yeah, I don't care about the 1, I already know it's a 1. The 7 times 5n, 35n, that's a horrible 5, 35n, and then the 42 and the 3 cancel Genesis to give me a 14, and thank goodness for the calculators, we're going to multiply that negative 14 by the 11n. Negative 154. And then we're going to cancel the 42 and the 14, Michael, to get
3
times the 19, and also thankful for calculators. 57n. And then 42 times 2, it does not cancel. This is over 1. Don't cancel to get a 21. Multiply by the 2, Abby, to get
84.
84. Okay, and then we're going to plug this into the calculator because they're all n's. 90 plus 35 minus 154 plus 57 gives us how many n's, class? 28n is equal to 84. And we're going to divide both sides by 28. And if you're not sure if it comes out evenly or not, instead of dividing, use the fraction button. 84 fraction 28. That way, if it doesn't work evenly, it'll reduce for you. And if it does work evenly, it'll still divide for you. You can't lose when you use the fraction button. So what is 84 fraction 28? It comes out evenly to 3. And there's our answer. And how many did get n equals 3? All right, questions on this? Go back and look at number 3 now. Question is, what is the LCD? Call it when you've got it. In many ways, that's the hardest part of the problem, is figuring out what the LCD is. What?
900.
It's not 900, but that is, by the way, that is a common denominator. Let me throw this thought out there. Ideally, LCD gives us the smallest numbers, right? But if it takes too long to figure out an LCD, just go with anything that's common, right? 900 would work. Nothing wrong with 900. There is a smaller number, though. No, 300, 9 can't go into 300. But you don't figure it out by the time I'm copying it, we're going with 900. All right, we're rolling with
225.
What?
225. Wait a minute.
6 can't go into 225. All right. All right. So the number was 450, by the way. You got a 5 times 3, a 5 squared, a 3 squared, a 2 times 3, and a 3 squared. But anyway, if you don't figure it out, that's okay. Because we're just going to roll with Michael's 900. All right? So, cancel. It's okay. Your calculator does all the work for you. That's the beauty of this. We're going to cancel the 900 with the 15 to get what? 900 divided by 15.
60.
You know it has to work evenly, so you can use the division key. It's not a problem to use the fraction key, though. And then 60 times 2x, 120x. All right, and then 900 is going to cancel with the 25 to get
36.
times 5x,
180.
180x. I know the numbers are big, but you know it's okay. Then we're going to cancel. You can do this one in your head. The 900 with the 100, and that's going to, of course, give us
400.
negative, careful, 400x. And then the 900 and the 6 going to cancel to give me 150 times x, 150x. And the 900 and the 9 again going to cancel to give me 100 times 1, 100. Just so we showed every step there. All right, and all the x's are together, which doesn't normally happen, but it worked out this time. We're going to combine all of these x's. What do we end up with?
Can we take out a
50x equals 100, so x equals 2. By the way, I like what Michael said. Hey, everything ends in a 0. Can we just knock off the 0 and we don't have to type as many numbers into the calculator? Sure, you end up with a 5x equals 10, so x still equals 2. I like that idea. Though since the calculator was doing the work, I guess I really didn't think about it, but that's a smart idea. I like that. See, favorite student status squared. All right, y'all gonna have a lot of work to do. Keep up with Michael. Questions on this? I was like, what happened?
No, I said the same thing.
Oh, you did?
I said bless you.
I only heard Michael.
It's like, what?
That's true, you did say bless you. All right, look at number 11 now. Copy this onto your paper if you would. We're going to do this one together. 10m plus 3. Poor Abby. And I mentioned this a moment ago, but my suggestion would be, if it's not a fraction, go ahead and put it over 1 just so you don't accidentally cancel where you shouldn't. This is a strategy tip. You don't have to do that, obviously, but I've seen students accidentally cancel with something that was not a denominator because they didn't really pay attention. So if you put it over 1, you're more likely to pay attention. Easy LCD this time. 24. No, 6. Good. I was just waiting for that one. Yeah, 6 is our easy LCD here. And of course the 6 and 3 easily cancel, class, to give me a 2. And notice we've got a 2 being multiplied by a grouped quantity. The fraction bar already grouped this. So the parentheses that we drew for the multiplication say, yes, they're there, but there's already a grouping anyway. So we're going to need to distribute the 2. Does that make sense? What do we get when we distribute the 2, Audrey?
21 plus 6.
And then here the 6 and the 2 are going to cancel, class, to give me a
Oh, wait, we're on 3.
a 3. But it's a negative 3. And we're going to need to distribute the negative 3 to get what, Brandon?
-18m positive 21.
Good. Negative 18m, positive 21. And then here, does anything cancel, class? No. We just multiply 6 times 10 times m minus 1. Strategy tip. Multiply the 6 and 10 first.
60.
Then distribute the 60 into the m minus 1 to get what, Abby?
60m negative 60.
There we go. And now it's just a matter of combining like terms over here, class, to get 2m, and combining these two numbers to get 27, and then got to get rid of the little m, Kendall, and move that over to the other side as a negative 2m to get. And while we're moving the m over here, let's bring the negative 60 over here as a positive 60 to get 87. And we have to, I know that ain't going to work out evenly. Put it in as a fraction. We end up getting what for our m?
1.5.
1.5. Or 3 halves. But if the calculator says 1.5, why would I do more work to get it out of that? Questions on this with polynomial numerators and the distribution that follows. Does that make sense? Questions at all on that? I want you to do number 7 there at your seats. I want you to do number 7 there at your seats. Again, the key to working with equations with fractions is to not work with the fractions at all. Just knock them out, go right back to what we were doing before all this. Watch out for negative signs, though. Brandon's finished. Gavin's finished. Number 7, Brecken. I like picking on Brecken. We miss you, Brecken. We really do. Abby's finished. Audrey's finished. Maddie's finished. Kendall's trying to figure out how to turn a calculator on. I'm just kidding. First thing I would do, I'm going to put this 4 over 1. That way it doesn't throw me off. I'm only looking at 3 numbers now. 6, 5, 10. What's my LCD? 30. How many multiplied everything by 30? Anyone multiply by something other than 30?
No, I almost did though.
Alright. 60 would work, 90 would work, 120 would work, 300 would work. Why would you want to do those? I don't know, but you could. Okay, it would still work as long as it's a number that has everything in it. I've taught students before who really struggle with this, and here's my strategy if you're struggling. Just multiply all the numbers in the denominator together, and whatever you get, use that as your common denominator. It will guarantee cancel everything. Now you're going to get some massive numbers, but your calculator's doing all the work anyway. All right, so 30 and 6 cancel, class, to give us
5.
5, which we need to distribute to get what, Genesis? And then the 30 and 5 are going to cancel, class, to give us
6.
but it's really not a 6, it's really a
Negative
6. So when we distribute, what do we get, Michael?
Negative 6r plus 12.
Good, negative 6r, positive 12. Good, here the 30 and 10, class, cancel to give me a 3, which I have to distribute to get what, Maddie? 3r plus 9, and then here nothing cancels. I just multiply straight up, class, to get 120. At this point, we need to combine all the r's together to get what, Brandon?
2R.
2r. Now let's combine all the nothings together to get what, Audrey? 26. All equal to 120. Then, of course, class, we're going to subtract away the 26 to get 2r is equal to 94. And when we divide away the 2, we get r equals 47. How many had 47 for your answer? Questions on this? How many missed a positive right here? That's always the first thing I would check for is who missed a double negative. All right, questions, comments? All right, you're going to practice with just a few of these for homework tonight. So keep your handouts for homework. We're also going to be working on them tomorrow. We'll work on them in the next lesson as well on Monday. So we're going to be on these handouts for a little while. Your homework is to do on the handout numbers 2, 6, and 10. On the handout, numbers 2, 6, and 10. And then back on page 97 in your textbooks, page 97, do numbers 5 through 10 and 21 through 24. Handout 2, 6, 10, page 97 in your books, 5 through 10 and 21 through 24. When the bell rings, you'll be dismissed, and have a wonderful rest of your day.